Hi everyone. I'm getting lots of questions about the Sapling assignment number 6 question specifically. I screenshotted one example. I think anyone who tries it probably going to get a different example, but the logic of how these are done is all the same. So I just wanted to just give you a couple hints on how you might get this one completed. So the question is basically giving you a pair of atomic masses of two different isotopes. And what they're doing is they're asking for what the percent abundance of each of those isotopes is. First thing that you need to know is you can't possibly answer this question unless you look at the periodic table. So you need to look at the periodic table to see what the actual average atomic mass is for whatever species you've been given. I've been given gallium. So if I look up gallium on the periodic table, I see that it has an average mass of 69.723 atomic mass units. So that's the first bit of information that you need to know. So you know that if you were to average each of the two atomic masses that you've been given relative to their percentages, you know you would get this number. So this is going to be an important number. The other thing that you know, which will be important in terms of you solving this question, is you know that whatever number you ultimately arrive at for gallium-69 or whatever isotope it is that you're dealing with in your question, if you added the two numbers, so the percentage of one plus the percentage of the other, that has to equal 100%, doesn't it? I mean, if that's everything, that's 100%. So with those two relationships, you can solve this problem. If I were to call this number, I don't know what it is, so let me just come up with a name for it. Let's call it percentage of 69. So percentage of gallium-69, let's call that. And then this one over here, again, I don't know what it is, but let's call it the percentage of 71. I can come up with a couple equations. So I know that the percentage of 69 plus the percentage of 71 equals 100. So that one I know for sure. I also know that the percentage of 69, if I were to divide that by 100 to get it in terms of a fraction, and multiply that by the actual mass of gallium-69, which this question tells me is 68.9256, and if I were to add this to the same sort of relationship but for the other isotope, so the percentage of the 71 divided by 100 multiplied by the mass of 71, so 70.9247. If I were to do this relationship, so, you know, whatever the percentage was, divided by 100, multiplied by this, do all this stuff here, I would find that that equals exactly 69.723. In other words, the number that came from the periodic table. So I've got two equations, this equation and then this one down here. Two equations with two unknowns, that's solvable. So hopefully I've bridged some gaps for you there. You should be able to use each of these equations together to solve for each of the percentages. So good luck with that, and let me know if you have any more specific questions.